So in this module we are going to understand the second law from the Kirchoff's is called as Kirchoff's voltage law, or in short KVL. So imagine you have got a network or a circuit as shown in the figure, and it consists of the voltage source known as V4, resistor R1, resistor R2, resistor R3, and there is a resistor R5, and you have these black dots A, B, C and D. They are called as nodes into the circuit or junctions of the circuits. Simply node or the junctions. Now in the network shown in the figure, you have the voltage drop across R1 indicated by V1, voltage drop across R2 is shown as V2, across R3 it's called as V3, across R5 is called as V5. So because you have this single voltage source, there will be a current that will flow into the circuit, and that current will pass through these resistors, and therefore according to Ohm's law there will be the voltage drops across all of these resistors. Since the resistor R3 and R5 are connected in parallel, because you see the two ends of both the resistors are connected at the same nodes or same junctions, therefore they are in parallel, therefore the voltage drop across each of them is the same, or in other words we can say the V3 and V5 would be the same. Okay, but our focus in this module is to explain you what is KVL, Kirchoff's voltage law. So this law states that the algebraic sum of all the voltages around a closed loop is equal to 0. I repeat, KVL states that the algebraic sum of all the voltages around the loop is equal to 0. So we can write that V1 plus V2 plus V3 plus V4 is equal to 0, and that is nothing but your KVL. So just write in mathematical form V1 plus V2 plus V3 plus V4 is equal to 0. So this is how you actually can say that you have defined the KVL. Remember, V3 and V5 are same, so you can either write V3 or V5. So that's your KVL. This KVL can be applied to any circuit which is linear or non-linear, any circuit which is consisting of only passive elements or an active elements, or a combination of active and passive elements.